I forgot about describing transformers in the previous class. So here we'll describe how transformers work and how you can use transformers to solve problems. Just to hint, the way transformers work is not that they're these little robots that fold up into the shape of cars and can turn into things that save the world. This is a representation of a transformer. A transformer is basically a piece of iron or steel in the shape of a loop, or in this case, in the shape of the outside of a square. And on one side, there are a loop of wires or coil called the primary coil. And on the other, there's another loop of wires or coil, which is the secondary coil. And the transformer is set up so that the magnetic flux, which loops through the primary coil, goes through the secondary coil and vice versa. The iron, which is the thing in the shape of the loop, basically keeps all of the magnetic flux together so that it goes through all of the primary coil and the secondary coil, and very little actually goes out to the rest of space. The main thing that you worry about with transformers are the number of turns for the primary coil, that's called NP in this picture, and the number of turns in the secondary coil, which is shown as NS in this picture. Now, both turns, both primary and secondary coils, have the same amount of magnetic flux going through them. That's phi in your data booklets. And if they have the same amount of flux phi, they also have the same rate of change of phi with respect to time. That's delta phi, delta t in each of the primary and secondary coils. So the electromagnetic force, electromotive force for the primary is just this delta phi, delta t times the number of turns in the primary coil, the negative number of turns in the primary times the delta phi, delta t. And for the secondary, that's also the negative rate of turns times delta phi, delta t. Now, if delta phi, delta t is the same for both the primary and the secondary, that means that we could say that the ratio of EP to NP, or let's say VP over NP, is the same as VS over NS for both the primary and the secondary. Now, in the data booklets, that's recast as VP over VS is equal to NP over NS, but it really comes to the same thing. And there's also a relationship to the current, which is the same thing as IS over IP, and we'll get to that in the next view graph. Depending on whether the primary or the secondary coil has more turns in it, you can get either less voltage out than you put into it, or you can get more out. They call them appropriately step-down transformers or step-up transformers. Unfortunately, you can get more or less voltage out, but you can't get more or less power out. You can't get something for nothing. So to make sure that the input power is equal to the output power, we have to say that the voltage times the primary times the current in the primary has to be the same as the voltage in the secondary times the current in the secondary. And those are the primary power has to be the same thing as the secondary power. And so that gives us a relationship for the currents as well as for the voltage. So we have in the data booklets VP over VS is NP over NS, and that's also equal to IS over IP. That is, if you get more voltage out, you're going to get less current out, or if you get less voltage out, you're going to get more current out. As an example, suppose that we're using a transformer to generate some low voltage power to a lamp. And in this transformer, we know that the turns ratio of the primary to secondary is 8:1. And we know that the input voltage to this lamp is going to be 120 volts RMS. and that it delivers a power, RMS, of 36 watts. So here are 3 questions for you. One is, well, what is the output voltage of this transformer? What is the output current of the transformer? And what is the input current of the transformer? Well, the output voltage, we can just use the turns ratio, will be the input voltage divided by 8. So that would be 120 over 8, or about 15 volts. The output current, we know is, well, if we know that the output power is 36 watts, and we know that the output volts is 15 volts, then knowing that the power is the product of voltage times the current, we can say that the power divided by the voltage should give us the current. So we take 36 watts, divide it by 15 volts, and come up with 2.4 amps as the output current. Finally, for the input current, we could either say that, well, I know the output current is 2.4 amps, and this is a step-down transformer, so if I divide the output current by 8, I should get the input current of 0.3 amps. Or I could say that the input power has to be equal to the output power, and that's 36 watts. The input voltage is 120 volts RMS, so I could just divide 36 watts by 120 volts and come up with 0.3 amps. And voila, either method will result in the correct answer.